What's up, guys? Welcome to this video. We're going to have a little intro to hyperbolic functions. So if you have no idea what they are, this is the perfect place to start. If you've never watched my videos before, highly recommend you write things down, pause, try the examples when prompted if it's appropriate, and there are always free guided notes available at divideandconquermath.com. So let's just jump right into it. So hyperbolic functions, they're defined, we can start actually with the hyperbolic sine and hyperbolic cosine functions. And so you might be thinking, oh, it's just trig. So it's not, but it's like kind of like trig. So first let me just show you the definitions of these. So we have this, so it's sine h of x. That's what this looks like. I'll tell you how to actually say this in a second. So here's actually how we define it. So it's very different from how we do trig, right? Where trig, we're usually relating it either to triangles, or sometimes we think of like visualizations with the unit circle. Hyperbolic functions are actually related to e to the x and e to the negative x. So here's your sine h of x and then your cosine h of x. So the h obviously stands for hyperbolic. So just kind of making that clear. So this is the hyperbolic sine, hyperbolic cosine. Really the only difference between these, right, is this one's negative, this one's positive. Otherwise, they're basically the same. And we have a special way that we say at least these two functions. So for the sine function, so we say sinh, which is like pinch. So we'd say sinh of x, but we know that it means hyperbolic sine. And then for this hyperbolic cosine, it's cosh, like, oh my gosh. So like gosh, right? So that would be the hyperbolic cosine. So those are kind of the two basic functions, and then from there, so we get a lot of other functions that, again, feel very similar to working with trig, but they present themselves a little bit differently. So let's go through some of the other ones. So there's this hyperbolic tangent, and so the good news is it is defined exactly how you would think, and then this is kind of what would happen if you were to use the definitions of sinh and cosh. This is what that would come out to. And then there's also the hyperbolic cotangent. And so that works, again, very similar to probably how you'd expect. And then you just like flip the result upside down, or flip-flop it. That makes sense. And then there is also hyperbolic secant, which again is defined in a very similar way to what we'd think with trig. So here's the definition here. If you kind of work that out, again, makes sense. And then we've also got the hyperbolic cosecant. And so just also FYI, it's not like we have a nice way to say all of these. So it's always funny in my classes. Sometimes my students will start trying to come up with things, which like when we start getting to cosecant, it's like, I don't know. I don't know how you could say that. If you want to present in the comments maybe some ways to pronounce these, go for it. Okay, so these functions, though, they work very differently from trig. So they're like kind of like trig, but kind of not. So you really want to respect them and don't just write this off as, oh, it's just like trig with an H, whatever. It's not. It behaves very differently. So the first thing I want to do, I actually want to go on an internet field trip. So pack your bags. I'm going to show you what the graphs of these things look like. So let's go. So this is Desmos.com. This is where our internet field trip is. If you've never been to Desmos, I always like to make sure people know, but this is a free website. It's a graphing calculator website. Come for the graphing, stay for the crazy things that people come up with on their software. So these are like art and things that people come up with graphing software. So, you know, math people were a lot of fun at parties. Okay, so let's go ahead and take a look at some of these graphs. So here's your hyperbolic sine, your sinh function. So this looks totally different, right, from how the sine function looks. And all you have to do if you want to try these at home, just type whatever the function is right here, by the way. So looks totally different. So like I said, it kind of has some things that are sort of like trig, but then other things are not. And then if we look at the cosh, oh my gosh, so again, totally different from what the cosine function looks like. So sine and cosine, they're usually, maybe I'll compare. So here's the sine function, right? So sine and cosine work very similarly to this. But if you compare that, then if I just put that hyperbolic kind of looks totally different, right? So that's kind of the point I wanted to make. Okay, so I also want to show you just the other ones. So here's your hyperbolic tangent. Again, totally different from the graph of tangent. And then if we look at hyperbolic cotangent, again, totally crazy. We'll look at hyperbolic secant, and then we'll look at the hyperbolic cosecant. So this is really just to kind of get it in your head that you don't want to totally think of everything as just a trig function. It behaves very, very differently. And sometimes referencing the graph is a really good way to kind of help you wrap your mind around how these functions work. And part of the key to this is knowing that there are some things that are like trig, but some things that are not, and this is a good way to help you kind of wrap your head around that. Okay, so let's go back to what we were talking about. Now, the best way to really wrap your head around hyperbolic functions is to actually explore some of the identities. So here is where we're going to start. So I want to actually figure out what is this identity. So we're going to play around with this. So this will help us to kind of figure out where there are similarities with trig functions versus where these just totally deviate. So where I'd want to start with this is actually I just want to use the straight up definition of sinh and cosh. So remember, sinh was e to the x minus e to the negative x divided by 2, and then this one is e to the x plus e to the negative x divided by 2. Okay, so there's the first part of this. Now just by looking at this, right, you can see that these 2's definitely drop out. And then this is kind of like if I'm multiplying this top piece together, so this is like kind of looks like a difference of square type thing, right? So if we work all of this out, so let's see, we get e to the 2x minus e to the negative x, e to the x, plus e to the negative x, e to the x, and then minus e to the negative 2x. So that's the top, and then we still have that other 2 that's still left over. So you can see then from working this out, these drop out, and so I'm left with e to the 2x minus e to the negative 2x over 2. And this looks quite similar to the definition of our sinh of x, right? Except the only difference now is instead of having just x here, now we have 2x. So what this means then is that this equals sinh of 2x. So that's actually what this identity would be. So just to round that out, so this means that 2 sinh x cosh x equals sinh 2x. That's what we just proved. So kind of a different set of identities here. So let's do one more. So I think that this would actually be a great one for you to try on your own, just to try to get used to working with this. So once again, you're going to want to set this up. So you're going to take that same definition. So here's your cosh of x, and you're going to square it. And then this one's going to be, oops, sorry, this one's supposed to be plus, this one's supposed to be the minus. Okay, so there's my cosh and my sinh functions, each squared. So what I would recommend that you do now is actually try to work this out and see if you can figure out what this actually comes out to. So it's going to take you a second, but this is a really good way to make you more comfortable with hyperbolic functions. So pause the video here and then hit play when you're ready to kind of review the answer. Okay, so if you're playing along at home here, so first you've got to kind of foil out the tops. So I will go ahead and foil both of these. So this is e to the 2x plus 2 e to the x, e to the negative x, plus e to the negative 2x, and then all of this over 4. And then for this one, this is e to the 2x minus 2e to the x, e to the negative x, plus e to the negative 2x, again all of this over 4 because you're squaring everything. Now one thing I didn't do in the last example, because it didn't necessarily matter because everything dropped out, was I didn't really think about what does this mean. So e to the x and e to the negative x. So you can actually combine those exponents because they have the same base. So you're just getting e to the 0. So this just equals 1. So this whole thing then will be just 2 times 1, so this just equals 2. So now what I want to do, oops, and I just realized sorry about that, I wrote a 2 there, I meant to write a 4. Okay, so now what I want to do is I basically want to write all of this over just the same denominator just to help me collect this. So I want to distribute this negative, and I'll rewrite these 2's. So what this comes out to is e to the 2x, now this is just 2, plus e to the negative 2x, and this is minus e to the 2x. This will be plus 2, and then this will be minus e to the negative 2x. So notice I just distributed this negative to each part of the problem, all of that over 4. And now you can see by looking at this, so this e to the 2x, those will drop out, and these drop out. And so now you're just left with 2 plus 2, so this is going to be 4 over 4, so this just equals 1. So this is a very interesting result. Again, it's very different from what we'd get from trig, right? So you get that your cosh squared of x minus your sinh x, this actually equals 1. So there's your other property. So this is a really good way to kind of wrap your head around how these functions work and why they're different. So the work to do it is not, it's just a little bit of algebra, and a lot of times it's just going to kind of come together like you see here. So if you're really struggling with this, I know it's a lot of time to actually sit down and do it, but I think it's one of the better things you can do to really understand how these things work. So, and then the other thing that I kind of keep telling you is, so these are kind of like trig functions, but not totally, so you just want to be careful when you're working through this. All right, so without further ado, now let me show you all of the hyperbolic function identities. So I'm just going to put these on here. So to prove them, we did the first 2, right? So we've done these 2. So there's a whole list I'm going to show you. So if you want to write these down, you can pause the video and write them down. So this is the first list. And then here's the next list. And so you'll notice if you compare these to your list of trig identities, some of these are going to be very different. So again, pause and write down what you need. And you should definitely try proving these on your own for fun. That will make you more fun at parties. Here's the scene that I always think of when I think of proving these. So that's it for this one. That's your intro to hyperbolic functions. So hopefully that was helpful. That should hopefully get you started on this. So I have other videos on this, so feel free to check those out. And I'll catch you guys next time. Thanks for watching.